So here I am in the middle of page 2 of your handout. And we wrote in the difference quotient. We said that this is an expression for the slope of the line through 2 points on our graph. So the slope of the secant line. And we have this big exciting star down here that says, if we could let the 2 points get closer and closer together, so close that the distance between them is 0, what we're going to have is the slope of the line tangent to the curve. And it turns out that the tangent line, our best definition for it is the line that has the same slope of the curve as at that point. So this is the definition for slope of a curve at a point. It goes on the top of the next page. This is the definition for the slope of a curve at a point. And notice it's exactly the same as the difference quotient you wrote on page 2 of your notes for the slope of the secant line, with that idea that we're going to let the 2 points get closer and closer together until the distance between them is 0. So that h, which is the difference in the x values, becomes 0, or approaches 0. We could never actually let it equal 0. We're going to have the same divide by 0 problem that we talked about at the beginning of this chapter. A very common type of problem on the AP test is they would ask you to give the equation of the line tangent to a curve. So the line tangent to a curve, it's going to be the line that has the same slope as the curve, which you would compute using this expression up at the top of this slide, through and contains the point of tangency. So you would be given some ordered pair and asked to find the slope using this process. Then you would have the slope and an ordered pair. You could use point slope form for the equation of a line to write the equation of that line. We're about to use that difference quotient notation a lot in the next couple of days, the next couple of weeks. So we want to make sure we really understand what this notation f of a plus h means. So we're going to practice a few of these examples. So if y equals f of x is a function of x, then f of a means to take that function rule and everywhere you see an x, you're going to replace it with a. Well, similarly, but definitely more complicatedly, f of a plus h means take the f of x rule and anywhere you see x, you're going to replace it with a plus h. Now, if there's any confusion, you might want to keep the a plus h in parentheses until you can tell really how you're going to operate with it. So some examples here. If f of x is 1 over x, then f of a is going to be 1 over a. So you can see that everywhere I had an x in the rule, I circled exactly what I didn't want to circle. Everywhere I had an x in the rule, I replaced it with an a. And f of a plus h is going to be 1 over a plus h. So if you could think about what that function does to its input, and then make sure you do that to a, do that to a plus h. So the next 3 examples you're going to try on your own. Sorry, I meant 2 examples. So I just did example, you're going to do the 2 practice problems. So here's the example in the middle of page 3. We've been given a function, f of x equals negative 16x squared, and we've been asked to find the slope of f at the place where x equals 5. So we're going to start with the definition you wrote down at the top of the page. Definition for slope of a curve at a point. So what's standing in for f of x? It's negative 16x squared. What's standing in for a is 5. It's this x value that's been given. So if I wanted to write a note, a is going to equal 5 in our problem. So I've started with this definition. We're going to try our best to evaluate it. Try not to accidentally divide by 0. See if we can simplify it. Let's see. Let's scooch me out of the way. Okay, so f of a plus h means we're going to take negative 16 and multiply it by a plus h squared. But we know that a is 5, so that's why I get this negative 16, 5 plus h squared. Minus, I'm going to find f of a. That just means f of 5, so that's my f function with the x replaced with a 5. That's where I get this negative 16 times 5 squared. So we're going to simplify here. Remember, 5 plus h needs to get written out twice. 5 plus h times 5 plus h. Now, if you multiply it in your head, that's fine. I just want you to make sure you do enough work that you don't accidentally make that error of saying that 5 plus h squared is 25 plus h squared. That's the error. Make sure you don't make it. So I'm going to simplify here. Let's see if I can drag my picture down. And there are many ways you can go about this simplification. Just make sure you notice what happens here with this subtraction of a negative result. You can simplify, and we're going to have what we got used to having happen back in section 2.1, which is we're going to be able to simplify that numerator. And look, I'm going to have an h that's going to cancel out. Watch this. So there are many ways to factor this rational expression here. So one way that I factored negative 16h out to the front. I have 10 plus h is left on the inside, and I notice that I'm going to be able to cancel the h in the numerator with my h in the denominator. Here's the h's will cancel, if you'd like to think of it like that. My new expression, the limit as h approaches 0 of negative 16 times 10 plus h. Now, I didn't actually try it before. I suppose I could have tried at the beginning, substituting 0 in for h to see if it worked. But I can tell right away I'm going to have a divide by 0 problem. But now, once the h in the numerator and h in the denominator cancel, I can substitute 0 in for h. I no longer have a divide by 0 problem, and I have my result. The slope of the graph of y equals negative 16x squared at the place where x equals 5 is negative 160. So that next question asks us to take the result from this example we just did and use it to write the equation for the line tangent to f of x at the place where x equals 5. If I'm going to write an equation of a line, I need the slope of a line, the slope of the line. In this case, we just figured out that the slope has to be negative 160. I'm going to need an ordered pair. So the only extra work to do here is that I know the x-coordinate of my ordered pair is going to be 5. I'm going to have to use the function f of x to figure out what the y-coordinate is. So that's the work you see here. When x equals 5, my y-coordinate is going to be f of 5, which is negative 400. That's how I get my ordered pair. Once I have an ordered pair, I already know the slope. I'm going to write the equation of the tangent line. You could feel free to leave it in slope, point slope form. You could write this equation in any form, and it would get full credit on the AP test. We'll do one more example. Note we need one new vocabulary word, the normal line. So if the tangent line to a curve is the line that has the same slope as the curve at that point of tangency, it's the line that if you zoomed in on the function until it looked like a line, it's the tangent line that it would look like. So it's the line that's the very best fit for the curve at that one point. So that's tangent line. The normal line is the line that contains the same point but is perpendicular to the tangent line. So the only new math here is going to be that we're going to need to figure out the slope of a line perpendicular to a line we already know the slope of. So we're going to have to find the opposite reciprocal slope and use the same ordered pair in point slope form. So here's another example. What if I want to find the slope of the graph of f of x is 1 over x at the place where x equals, and I'm not going to give you a number, we're just going to call it x equals a. So we're going to use that same process. I'm going to start with my expression for slope of a curve at a point, and that's the limit as h goes to 0 of the difference quotient that we use to find slope. So here's my expression for the slope of a curve at the point where x equals a. We've practiced already figuring out what f of a plus h would mean for the 1 over x function. So this is my expression. And probably you recognize this. This is one of those problems that I can't substitute 0 in for h because I'm going to have divide by 0 problem. But we have a technique that we can use, and that's the getting of a common denominator. If I can rewrite this expression so I have a common denominator in the numerator and then a common denominator in the denominator, which I kind of already have, then I can change this division problem to multiplying by the reciprocal of the denominator. I'm going to be able to simplify. So that's what's going on here. I'm very sorry that when I turned on my slide, the fraction bars and some of my fractions were missing. So I've handwritten them in, that's why they're wobbly. So my common denominator up in the top half of my rational expression is going to be a plus h times a. So I'm going to take that first fraction, multiply by a over a. I'm going to multiply the second fraction by a plus h over a plus h. You can see my new expression here. Now my two fractions in the numerator have the same denominator. Watch what happens. I can subtract. So my new, let me put one more step in here, just in case that's helpful to you. This is going to be the limit as h goes to 0 of, that's one giant fraction over h. And in the numerator, I'm going to have one giant fraction over a times a plus h. And in the numerator of that top fraction, that's why we call them complex fractions, I'm going to have a minus, this is the part where you can't forget to use some kind of grouping symbol. If I want the difference between a and a plus h, that's a minus the quantity a plus h. That's an a plus h. And we have to not forget to distribute that subtraction. That's probably the most common algebra error in calculus, is to not distribute that subtraction. So now that I have one fraction divided by one fraction, you can see here I've switched to multiplication by the reciprocal of the denominator. A minus a plus h simplifies to negative h. I have an h in the numerator and h in the denominator cancel. And here is my expression that's not going to give me a divide by 0 problem when I substitute 0 in for h. So the slope of the curve 1 over x at the place where x equals a is negative 1 over a squared. And that's a giant deal, because since I used a variable for my x value, I now have a formula that tells me the slope of this curve at any x value. So to find the slope of the curve at the place where x equals a, at a place where x equals whatever my favorite number is, I'm just going to substitute my favorite number in for a in that expression. So that's a big deal. This is maybe not our first time. This is an example of a function that's called a derivative. It can tell us the slope of this function at any place on the function. I have 3 more parts here, but these 3 are going to go really quickly compared to that first one. So part B asks us to find the slope of the curve, that's the same curve, 1 over x, at the place where x equals 2. Well, what we said is, what we found in the last expression, in the last problem, since we didn't use a number for x, we used a variable, is we ended up with a formula that tells us the slope of that curve at any point we want. So I'm going to simply substitute 2 in for a, and I get m as the opposite of 1 over 2 squared, so the slope is going to be negative 1/4. I can use that now to do what the next part asks, which is to write the equation of the line tangent to the curve 1 over x at the place where x equals 2. So what information do I need to write the equation of a line? I need an ordered pair. I need the slope. Well, I just figured out in part B that the slope of 1 over x at the place where x equals 2 is negative 1/4. The other information I need is an ordered pair. Well, I know the x of my ordered pair is 2. The question is, what's the y value on the 1 over x function when x equals 2? Well, it's going to be 1 over 2. So here's my ordered pair, 2 comma 1/2, and a slope of negative 1/4. And simply use the point slope form for the equation of a line. Feel free to leave your answer like this, or if you multiplied it out and changed it to slope intercept form or whatever form makes you happy, that's fine too. So this is our first normal line. How would I write the equation of the normal line to this curve at x equals 2? Well, I'm going to need an ordered pair, and it's the same ordered pair at 2 comma f of 2, so it's going to be 1/2. The only difference is now I'm going to use the slope for a line perpendicular to a line with slope -1/4. So I'm going to find the opposite reciprocal of -1/4. That opposite reciprocal is 4. So I'm going to write the equation of a line with slope 4 containing the point 2, 1/2. You can see I have that here.